Okay, so last video on metallic bonds. So metallic bonds are held together between atoms that are free with their electrons. And I suppose maybe I should use a different color because this is a little bit different from what we've said in previous videos. And the key word here is free with their electrons. There's a specific group of atoms that are free with their electrons, and it's specifically this block here in the middle. Typically, we've been ignoring this block. These are the transition metals. But the transition metals are special because not only do they give away their electrons, but they're free with their electrons. So let me show you what I mean by that. So we've got all of these iron atoms right here. And these iron atoms have valence electrons. And these valence electrons, I'm actually going to draw them a little bit different. I'm going to draw them like little negative signs. These valence electrons typically are bound to their atoms, so I'm drawing them very specifically around their iron atoms. But when I get enough iron atoms together, what ends up happening is these electrons are free to move around, and the iron atoms end up becoming positively charged. Because what they do with their electrons is they kind of throw them together in a pool. And that pool is able to move all around as it's attracted to different atoms. So these electrons end up being kind of like a sea of electrons, while your irons are positively charged, like this. And because the electrons are able to move around, we describe a metallic bond as a sea of electrons. They're not bound to any atom, they're not bound to any area. They're really free to come and go and move around as they please. So they're not stationary by any means. And if you were to look at the top of the ocean and you were to see the waves literally from a vertical view, you would see that the ocean is never at rest. And if you were to look at these free electrons, it would look very similar. They're never at rest in one place at any one point in time. They're constantly moving like the waves in the sea. So that's what actually gives these transition metals a lot of their amazing properties we're going to talk about on the next page. Before I move on though, if there's one thing that we take away from this slide, it's that metallic bonding is always between transition metals. That is key to metallic bonds. So let's talk about some of the properties. So I talked about how all of our electrons are free to move. I don't know why I put that in quotation marks, but we have free mobile electrons. And because we have free mobile electrons, we end up having positive atoms that are left behind as the electrons freely move about. And because we've got these positive atoms and these mobile negative electrons, we typically describe the structure of metallic bonding as a sea of electrons. And that sea is just really a very good visual description of the movement of those electrons. Now, because these electrons are able to move so much, that actually just provides a lot of the properties that we see in conductivity. Conductivity is all about how well do I conduct an electric current. Well, if I have this sea of electrons, I'm not just going to be a good conductor, I'm going to be a great conductor, which is why the transition metals, we talked about being the best conductors. And it's because they have that sea of electrons. Now for my physical properties, because I have the sea of electrons that can move around, this is going to make my metal very malleable, very bendable. My atoms are not stuck in place. There's a lot of movement going on because those electrons are free to move. And because I've got positives and negatives in close proximity to one another, this is going to make it difficult to separate. And it's truly because there's just positive and negative charges that are very attracted. So positives and negatives are going to be difficult to separate. Now, because they're difficult to separate, this means it's going to require a lot of energy for me to melt or even boil these metallic bonds. So that means I'm going to have to get to a very high melting and boiling point. Now, typically, metals are solids, and they're not usually soluble in water. They will react eventually, like rust is a reaction with water, but you don't drop copper in water and see that it melts, or you don't drop gold in water and see that it melts or dissolves, so they're not really soluble. So this wraps up our video on metallic bonds and metallic